This module covers general information about the SmogCheck program and inspection procedures. It is not all-inclusive and does not replace or supersede any applicable SmogCheck or Automotive Repair Act laws and regulations.
In this module, we will present the following elements of the SmogCheck inspection process: visual inspection, emissions test, functional tests, inspection results.
The SmogCheck inspection includes the following elements. A visual inspection is performed to ensure that the vehicle's emission components are present, properly connected, and have not been modified. An emissions test is then conducted to determine the actual composition of the exhaust gases. The emissions test is followed by several functional tests that are performed to confirm the operation of certain emission components. Inspection results are transmitted to the Vehicle Information Database, or VID. During the visual inspection, the inspector identifies the vehicle being tested and checks that the required emission control systems are on the vehicle and properly operating. Some vehicles may have aftermarket performance parts that need to be inspected for Air Resources Board certification and correct executive order number. The inspector is also required to check for liquid fuel leaks for applicable vehicles. The visible smoke test for gasoline engines consists of a visual inspection of a vehicle's engine crankcase and tailpipe for signs of smoke while the engine is at idle and during a bar-specified snap test. The bar snap test will be discussed later in this presentation.
The SmogCheck inspector verifies that the vehicle matches the registration renewal form and scans the information into the Emissions Inspection System, or EIS. The EIS accesses the VID to determine if the station is authorized to inspect the vehicle. After verifying that the vehicle information matches the Department of Motor Vehicles renewal, the renewal form may be used to enter information into the EIS only after verifying that it matches the vehicle being tested. If necessary, the inspector can enter the vehicle identification information manually.
Inspectors must use all available information necessary to determine the vehicle's emission control requirements, including, but not limited to, correct underhood emission control label, current emission control application guide, emission control repair manuals, emission component location guides, manufacturer emission control recalls and technical service bulletins, or TSBs, vacuum hose routing diagrams, California Air Resources Board, or ARB, aftermarket parts listings, and aftermarket parts label.
Using the proper reference material and the vehicle's underhood emission control information label, the inspector examines the vehicle to see if the required systems are installed and properly connected. The EIS provides screen prompts that direct the inspector to visually inspect the vehicle's emission control systems. For each system, the inspector manually enters one of the following into the EIS prompt: P for pass, S for missing, M for modified, D for disconnected, F for defective, N for not applicable. The inspector checks whether each required emission control system or component is missing, modified, or disconnected. A missing emission control system or component is one in which all or part has been removed from the vehicle or engine. An emission control system or component is modified if it has been disabled, replaced with a component not approved for installation on that vehicle, replaced with a component not approved for street use, or replaced with a component that does not function properly as designed. An emission control system has been disconnected if any hose, wire, belt, or other component required for the operation of the emission control system has been disconnected. The term defective applies to an emission control system or component that is worn, deteriorated, or broken, which will affect the operation of an emission control component or system. It is not a condition that occurred as a result of tampering. Examples of defective devices can be a hose, wire, cap, or thermal valve or switch disturbed and not reconnected or corrected when the vehicle was serviced.
Inspectors should refer to the correct underhood label and/or applicable reference materials to identify all required emission control systems for the vehicle. The following slides will discuss these systems in more detail. Please be aware this is not an all-inclusive list.
The positive crankcase ventilation system routes blow-by gases from the crankcase to the intake manifold to reduce hydrocarbons and carbon monoxide. The thermostatic air cleaner system supplies warm air during cold engine operation by allowing heated air from the exhaust into the air intake. During the visual inspection, the inspector must check that the required exhaust shroud, hot air duct, thermostatic vacuum switches, vacuum hoses, and air cleaner components are present and installed properly. An air cleaner lid installed upside down would be considered modified. There are several types of air injection systems, such as electric and belt-driven air pumps and pulse air systems. All introduce fresh air into the exhaust system to reduce hydrocarbons and carbon monoxide emissions. During the visual inspection, the inspector must check that the air injection system is present and properly connected. The fuel evaporative system prevents fuel vapors from escaping and contributing to smog-forming hydrocarbons. During the visual portion of the fuel evaporative system inspection, the inspector must check for the presence of a vapor storage canister and ensure that the required hoses, solenoids, etc. are connected properly. It is also necessary to check for the proper fuel tank cap and any non-OEM or auxiliary fuel tanks and associated fuel vapor canisters. Inspectors are not required to perform disassembly of the vehicle to inspect the fuel evaporative system. The exhaust gas recirculation system is designed to reduce oxides of nitrogen by directing exhaust gases into the intake manifold during certain modes of engine operation. EGR valves can come in a variety of designs and are typically controlled by engine vacuum and/or electronic controls. If an EGR system is required for the vehicle, the inspector must verify that it is present and properly connected. The inspector should refer to the vehicle's underhood label and/or use emission control system application guides to determine the proper EGR requirements. The computerized engine control system manages a variety of engine and vehicle functions and is designed to maintain an optimal air-fuel ratio. When the optimal air-fuel ratio is maintained, the catalytic converter can control oxides of nitrogen, hydrocarbon, and carbon monoxide emissions. The computerized engine control system consists of a powertrain control module, or PCM, input devices such as sensors and switches, and various actuators controlled by the PCM. The inspector should be sure to check for the presence of required sensors such as, but not limited to, the oxygen sensor, manifold air pressure sensor, coolant temperature sensor, and throttle position sensor. The inspector should also check for any tampering of computerized engine controls. Fuel injectors and carburetors control fuel delivery to the engine. The fuel metering system is examined to confirm that the proper components are installed. A fuel metering system may include airflow meters, injectors, fuel pressure regulators, throttle bodies, throttle positioners, anti-dieseling solenoids, early fuel evaporation devices, carburetor, choke controls, deceleration controls, and dashbots. The oxygen sensor or air-fuel ratio sensor is located in the exhaust manifold or pipe. There may also be sensors after the catalyst. Oxygen sensors compare the level of ambient oxygen to the level of oxygen in the exhaust stream and send a variable signal to the vehicle's powertrain control module. Refer to the proper reference materials and underhood label to confirm the number and location of the sensors. ensure that the oxygen sensors are properly installed. Ignition spark controls are mechanical or electronic devices that control ignition timing. The inspector must check to ensure that all parts of the spark control system are present and connected properly. The catalytic converter is designed to convert hydrocarbons, carbon monoxide, oxygen, and oxides of nitrogen into carbon dioxide and water. Most vehicles built from 1975 to present are equipped with one or more catalytic converters. Some vehicles have the catalytic converter located in the exhaust manifold, but most are located between the exhaust manifold and the muffler. Vehicles with multiple CATs have some located near the exhaust manifolds, commonly known as pre-catalytic converter or warm-up catalytic converter.
A multitude of cars. In each one, a motor burns fuel and produces toxic gases, nitrogen oxides, carbon monoxide, and unburnt fuel residue. Luckily, each car also has a catalytic converter. Located under the hood, attached to the motor, right before the exhaust system. Gases produced by the motor go straight into the catalytic converter and come out the other side less than 1/10 of a second later. The converter gets less than 1/10 of a second to recombine toxic gas molecules and produce harmless substances like water vapor and oxygen. How? To understand it, we've got to destroy it. The stainless steel housing contains 2 ceramic blocks. Each block is filled with thousands of microducts. Their sides are coated with precious metals. Precious? Platinum and rhodium in the first block. Platinum and palladium in the second block. Metals that can cost more than $100,000 a pound. But they're worth every penny. Together, they have the extraordinary property of causing toxic gases to react and then recombine, producing gases that are harmless to your health. All that without altering themselves or rusting. Precious. The trick is to maximize the contact zone between gas and metals. That's why there are so many microducts, almost 400 per square inch. Their combined surface area matches that of a football field. A laboratory as big as a football field, but folded onto itself in order to remain small. The transformation of gas from toxic to non-toxic happens most efficiently when the catalytic converter is hot. Very hot. 1,300 degrees Fahrenheit. It's the toxic gases themselves that heat up the catalytic converter. They exit the motor at temperatures as high as 900 degrees Fahrenheit. The chemical reactions inside the catalytic converter also generate heat, transforming the converter into a super efficient furnace designed to break down and reform gas molecules. Let's take a closer look at these mysterious transformations. The nitrogen oxide and carbon monoxide molecules, along with the molecules of unburnt fuel residue, enter the catalytic converter. They're swallowed up by the thousands of microducts. As they reach the platinum and rhodium in the first block, nitrogen oxide molecules are the first to react. These metals break down the molecules by withholding one of their atoms. The freed atoms stick to each other and recombine. The result? Nitrogen oxide molecules become oxygen and nitrogen, which already make up 99% of the air that we breathe. The gas molecules now head into the second block, where the microducts are coated in platinum and palladium. These precious metals withhold oxygen. The intense heat here forces the carbon monoxide molecules to combine with the oxygen. The result? Carbon dioxide, the same gas that creates bubbles in soft drinks. Now for the molecules of unburnt fuel residue. At these extreme temperatures, their encounter with the oxygen forces them to recombine. The result? More carbon dioxide and water. All that in less than 1/10 of a second. In theory, the catalytic converter can eliminate 99% of a motor's toxic gases. In reality, It's inefficient as long as it's not hot. A car has to travel about 6 miles before the catalytic converter reaches its ideal operating temperature. That's 6 miles spewing untreated gases. In spite of the catalytic converter's best efforts, the car remains a source of pollution. But thanks to this miniature laboratory, it emits 5 times less pollution. That's still pretty impressive.
The inspector must verify the correct number, application, location, and orientation of the catalytic converter as specified by the vehicle manufacturer. If a vehicle is equipped with parts that modify the original emission control configuration, inspectors must verify whether those parts are ARB approved or exempted. If the installed parts are not ARB approved or exempted, and the original emissions control configuration has been modified, the corresponding emission controls are considered modified, and the vehicle shall fail the inspection.
Aftermarket parts guidelines for gasoline and diesel vehicles are found in Appendix C of the SmogCheck manual.
A missing or illegible aftermarket parts label does not constitute an inspection failure. In cases where the label is missing or illegible, the inspector may proceed with the inspection, provided the parts can be confirmed as ARB approved or exempted by comparing the part number marked on the part with the ARB Executive Order parts listings or the parts manufacturer catalog. This is a screenshot directly from the ARB website showing the search engine for EO numbers, or search by EO or manufacturer for the device type. This screenshot confirms that the EO part number for the cold air intake system matches the vehicle application. This would be a pass in the Other Emissions-Related Components category of the EIS. A liquid fuel leak means any fuel emanating from a vehicle's fuel storage, delivery, metering, or evaporation system in liquid form that has created a visible drop or more of fuel. The fuel leak can be visible on a component of a vehicle's fuel delivery, metering, or evaporation system, or has created a puddle on, around, or under a component of a vehicle's fuel delivery, metering, or evaporation system. The liquid fuel leak inspection shall be conducted with the engine running. Use extreme caution when working around moving parts and ensure the transmission is in park or neutral with the parking brake on. The liquid fuel leak shall not apply to vehicles fueled exclusively by diesel, compressed natural gas, liquefied natural gas, or liquefied petroleum gas. Nothing in the liquid fuel leak inspection shall prohibit an inspector from refusing to inspect a vehicle or from aborting an inspection if a liquid fuel leak presents a safety hazard. The liquid fuel leak procedure is a visual inspection only. If no liquid leak is found, the vehicle shall pass inspection and the inspector shall enter P for pass in the Emissions Inspection System Fuel Leaks prompt. If a liquid fuel leak is detected, the vehicle shall fail the inspection and the inspector shall enter F for defective in the Emissions Inspection System Fuel Leaks prompt. The inspector must indicate on the vehicle inspection report the location of any liquid fuel leak. Inspectors are not required to perform disassembly of the vehicle to inspect for liquid fuel leaks. No special tools or equipment other than a flashlight and mirror are required.
The visible smoke test has 3 parts. During the idle test, the inspector observes the tailpipe exhaust plume for 10 seconds after performing the emissions test on the vehicle. For the crankcase test, the inspector observes the engine crankcase for 10 seconds. The inspector performs the bar snap test by quickly pushing and releasing the accelerator pedal from the idle position. Visible smoke test results are entered into the Other Emission-Related Controls category of the EIS. When using the BAR OBD inspection system or BAR OIS, you will be prompted when to conduct the visible smoke test and where to enter the results. The following video provides detailed procedures for this test using the EIS.
There are several steps that must be followed before conducting the visible smoke test. First, place the transmission in neutral or park with the parking brake on and/or wheel chocks in place. Turn off all accessories, including the air conditioning. Next, ensure the vehicle is at normal operating temperature as described in the Smog Check manual. Finally, position the vehicle to ensure there are no drafts that can disturb the exhaust plume. Make sure there is nothing in the shop environment, such as equipment or toolboxes, which would prevent you from clearly observing the exhaust plume. The first part of the check for visible smoke is a bar snap test. This test consists of pushing the accelerator pedal quickly from the idle position to between 2,000 and 3,000 RPM, then immediately releasing it to allow the engine to return to idle for at least 3 seconds between each snap of the accelerator. There are 3 bar snaps that must be performed. The first bar snap is performed before conducting the ASM or 2-speed idle test. This snap will help you to become familiar with the vehicle. Do not check for tailpipe smoke during the first bar snap test. The engine RPM may be viewed using the vehicle's tachometer or the analyzer screen immediately prior to the emissions test. You may also use an auxiliary tachometer to conduct the bar snap test. The final 2 bar snap tests are conducted later when the analyzer prompts for the other emissions-related components. For gasoline-powered vehicles, the idle test shall be performed immediately after performing the Smog Check emissions test. Upon completing the emissions test, leave the engine running. Remove the exhaust probe from the tailpipe. With an unobstructed view, watch the vehicle's tailpipe exhaust plume for 10 seconds. If smoke is observed, the vehicle shall fail inspection. Be aware that water vapor or steam is not considered visible smoke and would not cause a vehicle to fail the visible smoke test. The crankcase test should be performed during the visual check of a vehicle's emissions control systems. With the engine idling, observe the engine crankcase system for 10 seconds. If smoke is observed, the vehicle shall fail inspection. Smoke observed from any area other than the crankcase system, regardless of the cause, does not constitute a crankcase visible smoke test failure. The final 2 bar snaps are to be performed at the time the analyzer prompts for the other emission-related components. Perform the second bar snap while watching for visible smoke from the vicinity of the tailpipe. Return the engine to idle and wait for at least 3 seconds to allow the engine to stabilize. Now perform the third and final bar snap while watching for visible smoke. If any smoke is observed while conducting these final 2 snaps, the vehicle shall fail inspection. In this example, smoke was observed and the vehicle would fail inspection. Please note that visible smoke can most often be seen between 0 and 10 feet from the tailpipe. This completes the visible smoke test inspection procedures. Now, let's take a look at the pass-fail determination criteria. If no smoke is observed during the idle test, the crankcase test, or the bar snap test, the vehicle shall pass the visible smoke test. If any smoke is observed during any one of the 3 tests, the idle test, the crankcase test, or the bar snap test, the vehicle shall fail the visible smoke test. Here is an example of a vehicle emitting tailpipe smoke during the tailpipe idle test. This vehicle would fail the visible smoke test. After completing the visible smoke test, enter the test results into the analyzer. The results must be entered into the other emission-related controls category of the visual portion of the Smog Check inspection. However, the analyzer currently allows only one entry for the visual inspection of all components covered under the other emission-related controls category. Therefore, if the vehicle passes all 3 parts of the visible smoke test but fails a visual check of any other component covered under the other emission-related controls category, enter the appropriate failure code. P for pass, D for disconnected, M for modified, S for missing, or F for defective. Similarly, If a vehicle passes a visual check of any components covered under the other emission-related controls category, but fails any one of the visible smoke tests, enter F for defective. If the vehicle fails the visible smoke test, the technician is required to document the failure on both the customer's copy and the station's copy of the Vehicle Inspection Report, VIR. The failure also must be noted on the customer's invoice. Make a clear notation such as failed visible smoke test or failed for visible smoke. In addition, specify what parts of the visible smoke test the vehicle failed. For example, technicians may use terms like crankcase test smoke, idle test smoke, or bar snap test smoke. If applicable, list multiple reasons for the visible smoke test failure.
This section briefly describes the emissions inspection system and procedures for performing a tailpipe emissions test of the vehicle. The inspector places the probe in the tailpipe to perform either an acceleration simulation mode or two-speed idle test. The type of test required depends upon the vehicle and program area. The emissions inspection system consists of a 5-gas emission analyzer, a fuel cap tester, and in most cases, a dynamometer. The emissions inspection system is used to perform the acceleration simulation mode test and the two-speed idle test. The acceleration simulation mode emission test is performed by placing the vehicle being tested on a dynamometer, a treadmill-like device that simulates actual driving conditions for a more accurate measurement of the pollutants a vehicle produces. The vehicle is driven on the dynamometer at 15 miles per hour and again at 25 miles per hour. The calculated load is determined by the EIS. The EIS can perform the two-speed idle emissions test when an ASM test is not required or on vehicles that cannot be physically tested on the dynamometer. For example, a vehicle with a full-time four-wheel drive or a non-disengageable traction control cannot be tested on a dynamometer. The two-speed idle test includes two test sequences: a 30-second 2500 RPM test and a 30-second idle test. A functional test must be performed on vehicles when applicable. This slide indicates the functional tests needed for each vehicle depending upon model year, weight, fuel type, and equipment applications. All 1995 model year and older vehicles equipped with an EGR system and subject to a two-speed idle test shall undergo the EGR system functional test. Vehicles that undergo an ASM test would not need an EGR system functional test because the EGR system operation is reflected in the sample reading collected from the ASM test. Inspectors must follow the functional test procedures prescribed by the vehicle manufacturer.
All 1995 model year and older vehicles equipped with EGR and subject to a two-speed idle TSI are required to have an EGR functional test performed. The EGR's main function is to help reduce NOx emissions. Since the TSI test does not measure for NOx emissions, as with the ASM test, the EGR system needs to be tested for proper operation. The technician must follow the functional test procedures in the vehicle manufacturer's service manual or the emissions system application guide, as there are several different types of EGR systems depending upon application. Some EGRs are electronically operated, as in the example shown here. Other EGR systems are vacuum operated. In this example of an EGR functional test, this system is vacuum operated. The system first needs testing for a proper vacuum supply reaching the EGR valve under appropriate conditions. Then the EGR valve and EGR passages need to be tested for proper flow. With the engine running, apply a vacuum to the EGR valve. If the valve opens and the passages have proper flow, the engine should stumble or stall.
Now let's look into the basics of ignition timing. It is the process of setting the point at which the spark will occur in the combustion chamber relative to piston position and crankshaft angle. Ignition timing is measured in degrees before top dead center and is usually adjusted by rotating the engine's distributor. On late model vehicles, the powertrain control module adjusts ignition timing based on engine control sensors. Inspectors must check the base ignition timing using vehicle manufacturer procedures. Many underhood emission labels provide procedures and specifications for checking the ignition timing. If no label is present or if the procedures are not on the label, the inspector must refer to an Emission Control Systems Application Guide or appropriate service manuals. If no RPM is specified for the timing check, the idle speed must be within 100 RPM of the base idle speed. To pass inspection, the base ignition timing must be at manufacturer specification plus or minus 3 degrees. If the timing is found to be more than 3 degrees in either direction from manufacturer specification, the vehicle fails the functional test. If the manufacturer provides a timing specification range, the 3-degree tolerance is not allowed. Engine speed must be within the specified RPM range.
If the underhood emissions control label, an emissions application guide, or other reliable manufacturer-derived references indicates timing is not adjustable, then the ignition timing test is not required. If the timing cannot be measured due to a mechanical defect, such as a slipped harmonic balancer, the vehicle shall fail the timing test. The EIS includes a provision to account for mechanical defect. Follow the EIS prompts and document the mechanical defect on the vehicle inspection report.
The vehicle's base ignition timing shall be checked using the manufacturer's procedures. Many underhood emissions labels provide procedures and specifications for checking ignition timing. In this example, the ignition timing is computer controlled, and as the underhood label indicates, the base timing is 10 degrees BTDC, before top dead center, with the diagnostic connector short-circuited in order to check the base timing at idle. The timing needs to be within plus or minus 3 degrees of manufacturer specifications or within the range provided by the manufacturer if specified. The timing needs to be checked at idle speeds plus or minus 100 RPM of manufacturer specified idle unless otherwise specified by the timing procedure provided. Procedures can also be found in the Emissions Control Application Guide or an appropriate service manual. Vehicles listed to have not adjustable timing and/or vehicles with computer-controlled ignition systems that do not have timing adjustments are exempt from the ignition timing test even if the timing specifications are listed. Any mechanical defects where the timing cannot be measured will be entered as a fail for the ignition timing portion of the smog inspection.
All 1996 model year and newer vehicles have computer-controlled emission control systems, which have onboard diagnostic capabilities. Vehicles are equipped with standardized diagnostic data link connectors, or DLC, which the inspection systems, both EIS and OIS, can connect to and collect diagnostic information. The SmogCheck OBD2 functional test evaluates and reports the status or results of the readiness monitors. This is automatically performed by the inspection systems, both EIS and OIS. The location of the DLC can be found in appropriate electronic component location manuals or emission control diagnostic and repair manuals. The DLC may provide an RPM signal that in most cases can be used during emission test sequences. The inspection systems, both EIS and OIS, assess the OBD2's system's ability to communicate the readiness of system monitors, the diagnostic trouble codes, and MIL command status. DLCs are typically located on the driver's side underneath the instrument panel, but some can be located in the center console or on the passenger side of the vehicle. A cable from the inspection system either EIS or OIS, is connected to the vehicle's DLC to check for trouble codes and monitor status stored in the powertrain control module.
The malfunction indicator light or check engine light shall be checked on all vehicles equipped with an OBD1 or OBD2 system. To check malfunction, the inspector must turn the ignition to the key on, engine off position, observe the mill, and then start the engine, key on, engine running. The mill should be on in the key on, engine off position, and turn off when the engine is started. A pass entry indicates the mill properly operates and service or repairs are not needed. A fail entry indicates the mill is not on with the key on, engine off, stays on, or flashes with the engine running.
When applicable, the malfunction indicator light, MIL, or the check engine light shall be checked on all vehicles equipped with an onboard diagnostic system 1 or 2, or OBD1 or OBD2. To check the MIL function, the technician shall turn the ignition key to the key on, engine off, KOEO position, and observe the MIL operation. The MIL should illuminate. The technician should then start the engine, key on, engine running, KOER. The MIL should extinguish when the engine is started or within a few seconds of starting. A MIL that does not illuminate in the KOEO position or stays on continuously after the engine is started is entered as a fail for the MIL functional test of the smog inspection. The Smog Check OBD2 functional test evaluates and reports the status and/or results of the readiness indicators, system faults, and MIL. The process is an integral part of the Smog Check inspection, requiring minimal technician input. The technician must always use all available information necessary to determine the vehicle's OBD2 requirements, including but not limited to the underhood emissions control label and underhood vacuum diagram. Many publications are also available, such as a current emissions control application guide, emission control repair manuals, emission component locations guides, manufacturer emission control recalls, BAR OBD technical advisements, and any reliable vehicle manufacturer sources.
This test applies only to 1995 model year and older vehicles equipped with evaporative emission control systems. During the fuel cap integrity functional test, the inspector must refer to the fuel cap tester application manual to determine if there is a cap adapter available for the vehicle being tested. If none, enter no adapter is available. Follow the EIS and fuel cap tester prompts to complete the test. The test results are manually entered by the inspector into the EIS. As prompted by the EIS, perform the fuel cap integrity test on all 1976 to 1995 vehicles equipped with evaporative controls that operate on a gasoline, including dual bi-fueled vehicles. The fuel cap integrity test is a two-part test made up of a visual and functional test. For the visual inspection, inspect the fuel cap or caps for proper fit and installation. If the fuel cap threads are stripped or the fuel cap seal is missing or damaged, the cap would fail inspection. If the fuel cap is not designed for the vehicle, the fuel cap shall fail the visual inspection. The inspection result entries are P for pass, F for fail, and S for missing. The functional check applies only to vehicles with evaporative emission control systems. Check the fuel cap tester application manual if needed to select and input the correct cap adapter. Following the EIS and cap tester prompts, attach the fuel cap or caps one at a time to the adapter and perform the test. Assure the fuel cap is securely attached and sealed. The fuel cap is automatically tested for its ability to hold a proper seal. When prompted, remove the fuel cap from the adapter. The test results are automatically captured by the EIS as a pass or fail. If the fuel cap fails, the EIS will give you an option to replace the fuel cap and retest the new cap for a proper seal. When the EIS has finished testing the first fuel cap, the technician is then given a choice to test a second cap if applicable. If no adapter is available from the tester manufacturer for the vehicle being tested, or the vehicle is newer than 1995, do not perform the functional test. Enter no adapter is available as prompted by the EIS.
The main components of the fuel evaporative system are evaporative canister, sealed fuel tank, liquid vapor separator, and vent lines to a vapor storing canister filled with activated charcoal or carbon. The filler cap is not vented to the atmosphere and is fitted with a valve to allow both pressure and vacuum relief. All OBD2 controlled vehicles monitor the evap during vehicle operation to determine system integrity. The low pressure fuel evaporative test is required on 1995 and older model year vehicles and checks the vehicle's fuel tank and evaporative system for leaks. During the test, the vapor hose is pinched off at the canister to seal the system. The LEPVET tester is then used to pressurize the fuel tank to approximately 0.5 psi. When the system reaches the proper pressure, the tester monitors the system for excessive pressure drop. The tester makes a pass-fail decision based on how much pressure the system was able to retain over a specified amount of time. This is an example of a typical fuel evaporation control system. The vapor hose is pinched off as close to the canister as feasible to seal as much of the system as possible. BAR has certified 2 manufacturers to produce LEPVET equipment. Both systems include the following components: a tester, a device to manually calibrate the tester, filler neck adapters to attach the tester to the vehicle in place of the fuel filler cap, pliers to pinch off the vapor hose and seal the system, a calibration tank. The EIS transmits vehicle test results to the state's central database, also known as the Vehicle Information Database, or VID. Following the test, the EIS prints out 2 copies of the test results. The inspector signs and dates the VIR under penalty of perjury. A copy is retained by the smog check station, and the second copy must be provided to the consumer. All test results are stored on the VID. If the vehicle passes the test, a certificate of compliance is electronically transmitted to the Department of Motor Vehicles to meet registration requirements. Thank you for viewing Module 2 of the California Smog Check Program Training Series.